So we're looking at question 4 on the correlation and association questions on the integral maths. It says here the mass of heart and the mass of the liver in mice is sampled as follows. And here's the data. The mass is given in units of 0.01 g. So these are the masses and they're given in units of 0.01 g. Otherwise they'd be pretty big mice, wouldn't they? It then says, test at the 5% significance level whether this provides evidence that the masses of the heart and the livers are positively correlated. So it's a correlation. So remember, with the correlation, our rho is 0. And this is a one tail because they're saying it's positively correlated. So that's what they want to do there. Now, so it's one tail. And the question actually gives you, at the bottom, it says one tail, 5% value is 0.6215. So I know the critical value of a one tail one is 0.6215. So what I now do is I find my actual value, my R value, my test statistic, and I do that by going to my setup. Remember how we do that? We've got a table like that. I've inputted the data already. And so then I go to options 4 and it tells me my regression line is 0.2347. So there we go, 0.2347. And that's from the calculator. Now remember, if it's closer to 0, then there is no correlation. So if it's closer to 0, there's no correlation. My value is 0.2, the critical value is 0.6, so that is closer. So therefore, there's insufficient evidence. We're going to accept the null hypothesis. So I write in accept null hypothesis, and then I have to write there is now insufficient. You can see the language is very similar. And look how the caveat, insufficient evidence to suggest. There is, and now I'm going to use the words that they put in, a positive correlation between the masses of heart and liver in mice. Now, question to you, if these were done in the accurate measurements, not to the 0.01, would that change any of these results? No. If I doubled all of these, would that change it? No. Because you're actually seeing it from the variance from each other and how they deviate that way. So yeah, by just looking at this to the 0.01 doesn't actually change the end result. Okay? So there we go. Job's a good one.